7 centimeters straight out, it would not make a triangle. Okay, let's pretend that's 7 centimeters. But if I took out, I don't know, some glue stick or maybe a hammer and nail, I nailed it onto here so that that part was fixed, right, because it had to be there. I could swing this around. You see that it would swing like a circle? And it would eventually hit here, and if I drew this, that would make one triangle of 7 centimeters. But if I keep swinging it around, you see it would pass farther on the other side because its length is 7. There's only one triangle possible with the 7 centimeters. But when we did the 3.5, again, if I fix this onto here and I did 3.5 this way, which is one that most people got first, but if I kept swinging it around, there's a second triangle that's possible with 3.5. And then with 1 centimeter, I was like, oh man, swing that around. 1 centimeter was like way too short. You like, anybody try stretching their ruler, pulling on it, see if they can make the 1 centimeter longer? Didn't work. That would be bad if they made rulers that were elastic bands. And then you could make any length you wanted by stretching it. So 1 centimeter didn't work, and then I asked, what would the shortest distance be? And the shortest distance would be straight down, which would make a 90-degree angle. And if it made a 90-degree angle, you would be allowed to use SOHCAHTOA. If you're allowed to use SOHCAHTOA and you didn't know this side, you could set up that sine of 30 degrees has to equal x over the 5. And why can we do this without our calculator? Because that's one of our memorized numbers. From your special triangle, here's your equilateral triangle. 30, 60, 90. We made this 2, 2, 1, 1, root 3. What's sine of 30? Here's 30. 1 over 2. 1/2. What number has to be here to make it 1/2? 2.5. So with a triangle, sometimes there's the possibility of one answer. Sometimes there's a possibility of 2 answers. And sometimes there's a possibility of no answers. And with one answer, there's always a smallest possibility. Okay? So what I'd like you to do is I'd like you to say, I drew a new one. This time I made 80 degrees, and I made 7. Can you tell me a length that would make 1/8? Can you tell me a length that would make 2 answers? Can you tell me a length that makes 0 answers? Can you tell me the shortest answer possible? Yes.
The shortest answer possible is approximately 6.89.
6.89. And how do you figure out? So does it make sense? The shortest one possible would be when you make straight line down 90 degrees. So if I want to find that shortest one, I want to find this x. That would set up sine of 80 degrees is equal to x over 7. And now we just have to multiply both sides by 7 to get x by itself. And you're right, you get 6.89. So that's your shortest. Can you tell me a possibility then, if that's your shortest, what would be a number that would give you 0 answers? 1. Anything, does it make sense? Anything less than 6.89 will give you 0 answers because it just will not reach. Okay? What would give you 2 answers? 7 will not give you 2 answers because this one swinging around will match up perfectly and not make a triangle.
6.9.
6.9 would. 6.95 would. Something less than 7, but bigger than the shortest one. Because then it would hit, and when you swing around, it would hit again. What would give you a number that would make only 1, besides the shortest one? 8. Anything bigger than 7 can only be drawn on this side. Technically, we could keep going and eventually hit that line if I did 800. I might just have to go very far, far way out. So anytime your opposite of the angle side is bigger than the adjacent side, there's only going to be one possible, but always one possible. Even if it's like 800, you could eventually stretch it out and hit that triangle eventually. The shortest one will always be at 90 degrees. To have 2 of them, it has to be less than 7, but bigger than the shortest side. And anytime you're smaller than the shortest side, you're going to not be able to draw a triangle whatsoever. What we are starting to look at, and we are going to turn to 6.4. What we did here is basically the 6.3 activity. So exciting. We are going to look at a triangle that does not have a 90-degree triangle. And initially, we are going to cheat. Initially, we're going to cheat because we're going to draw the height. And by drawing the height, we make a 90-degree triangle. So the first thing that you have space for, number 1 here, it says, use triangle ABC to write an expression for H in terms of B and the angle A. So here's my angle A. And would you agree that sine of angle A is the opposite side H over the adjacent, the hypotenuse B? If I'm talking about a right angle triangle with angle A, I would get that sine of A is H over B. And if I wanted to, I could get the H by itself by multiplying both sides by B. I don't know. I don't know if you can sense there's excitement about to happen. We are about to develop trigonometry for triangles that do not have 90-degree angles. So that's number 1. Number 2, it says, now use the angle B. And I could write that sine of B. The opposite side is H, and the hypotenuse is A. If I use that right angle triangle. And I could get H by itself by multiplying both sides by A. Now, if H is equal to this, and H is equal to this, what does that mean about those two things? They're the same. So I could now write that B times sine of A has to equal A times sine of B. And we have just discovered the sine law. Now the sine law is usually written this way because it's easier to remember. They decide to divide everything by A and everything by B. When you divide everything by A and everything by B, can you see that the A would move underneath on that side? And if I divided everything by b, well, the b would go away from that side and divide everything on the other side by b. Right? Because you divide both sides by b, on the left side the b's would go away. And you'd be left with a b on the bottom on the right side. Divide both sides by a, the a's on the right side would go away. And you'd be left with an a on the bottom on the other side. Okay? Question. If I took that same triangle, I'll even steal it like this. Beautifully replicated. If I took that same triangle, and this was A, and this was B, no, this was A, and this was B, and this was C, and I rotated it to the right. Can you see that if I rotated it to right, now the A would be up here, the C would be down here, and the B would be down here? I could draw a new height. I'm going to call this one H2, because it's not the same as H1. It's a new height. Could I do all the same math again? But this time, what would my math show? My math would show that sine B over B is equal to sine C over C. And so the sine rule is interesting because it has three things that could be equal to it. And it is on the start of your next page, your sine law. And you can either write it with the angles on the top, or you could flip everything and put the angles on the bottom. Did you know that you could do that with fractions? Did you know that if 2/3 is equal to 4/6, if you flip both sides, it's still true? It should make sense that it's true, because the same, if you reduce 4/6, you get 2/3. And if you flip both sides, it's sort of like, well, now there's the other bigger numbers on top, littler ones on the bottom. But you can do that with your sine law as well. And we're going to find out that we're going to use the sine law when you know an angle and its opposite side. But sometimes when you know an angle and its opposite side, we're going to find out that two triangles are possible. Sometimes only one is possible. Sometimes none are possible. And sometimes we'll find the shortest one possible, and it will end up being 90 degrees. We also use the sine law when we don't have a 90-degree angle. The sine law works for any triangle, whereas SOHCAHTOA only worked if you had 90 degrees. I'll get you to add a couple of extra definitions just on the side of page 471. First definition is an angle of elevation, or angle of inclination. So if you have a horizontal line, and they say it has an angle of elevation of 20 degrees, you'd imagine that you would be looking up. This would be an angle of elevation of 20 degrees. So they'll often say a person spotted an airplane at an angle of elevation of 70 degrees. Or a ramp has an angle of inclination of 20 degrees. Because the ramp, you would start with your horizontal ground, and then that ramp is going 20 degrees up. So it's a way of being able to label an angle from words. And the opposite of an angle of elevation depression. And a very similar definition, but now you're looking down from a horizontal line. So you have a horizontal line and an angle of depression of 30 degrees would look like this. And we're ready for example 1. Everybody good? The first thing is you are going to be tempted to use SOHCAHTOA when you can, because you're so used to using sine, cosine, tan normally. The very first thing you look in this triangle is this a 90-degree triangle? No. Unfortunately, this adds up already to 95 degrees. So how did I figure out that this one was 85 degrees? I just guessed. No, I didn't just guess. How do I figure it out? Angles in a triangle add up to 180 degrees. The very mean trick to do to grade 6 students, but very fun, is to say, bonus marks for anybody who can draw me a triangle where the angles don't add up to 180 degrees by tomorrow's class. And then they go home and try to draw triangles all night. Is that kind of mean? By the end, they know that you can't draw a triangle that doesn't add up to 180. Okay, next. How do you know that you can use the sine law? The sine law is used whenever you know a side and its opposite angle. So I'm going to just highlight that slowly by taking out my highlighter and highlighting that I know this 51 and I know this 7.8. And I want to find this side. Little j is the length of G to H. So in your sine law, you can either put angles on top or sides on top. And as a general rule to make your life easier, always put what you want to find in your numerator. It's not that the other way is wrong, it just takes a little bit longer. So I want to find J. So the very first thing I do is I'm going to set up my sine law and I'm going to put J on the top. And the important thing about the sine law, if we just scroll back up and look at it again, we have A going with A, B going with B, C going with C. And when you're labeling a triangle, that's always the side opposite the angle. So in this situation, I am solving for J. Underneath, I'm going to put sine of, which is the one opposite of J, 44. So the opposites always go together in the sine law. And then in order to solve, we need an equation. Now I can choose a side and an opposite angle, but I'm going to have to use the ones that I know. So since I know the 51 and the 7.8 go together, I will put the 7.8 on the top and the sine of the 51 on the bottom. And the sine law is beautiful because now, how would I get J by itself? I'm dividing by sine of 44. What's the opposite of dividing? Multiplying, so I'm going to multiply this side by sine of 44. So now I got j by itself, and I can go to my calculator, and I can type this in all together. So I'm going to even use my oh, spoke too quick. I'm going to push this button. I'm going to push that button again. And then I'm going to push this button. And I'm going to push enter to get a fraction. And I have 7.8 sine of 44 divided by sine of 51. And it's that easy. Push enter. 6.972. Angle J to the nearest 10th. Oh, nearest 10th is a fun rounding question here. How do you round that to the nearest 10th? It'll be 7.0. Are there units? Yes. 7.0 centimeters. Circle question number 3.